Atoms were first conceived by the ancient Greeks, who believed that atoms were the smallest type of matter and the building blocks of the universe. Since then, things have moved on just a little bit. Welcome to Chemistry Visualized. If you find this video useful, please do consider leaving a like. Also, you can check out the webpage associated with this video. There should be a link in the description, and that's basically got what I'm going to say, but in a written form. In the early 1800s, John Dalton proposed a model of the atom where there were lots of little balls of matter, and when put together, built up everything we see around us. It then progressed to the plum pudding model, which is where there's a large area of positive charge with electrons inside it. However, in the early 20th century, there was a radical change in thinking. Ernest Rutherford and his colleagues actually believed all of the positive charge was condensed down into a small area called the nucleus, around which the electrons orbited. They set out to prove this in an experiment called the Rutherford Alpha Scattering Experiment. In this experiment, they fired alpha particles at a thin layer of gold. They then set up a detector to see where they landed. Based on the plum pudding model, you would have expected the alpha particles to land directly behind the detector, in line with the alpha source. However, this isn't actually what happened. The particles were deflected much more than expected, and some particles were even deflected by more than 90 degrees. To give you an idea of the significance of this, it's not unlike holding out a piece of paper in front of you and expecting it to bounce a bullet. I mean, it's just not going to happen, is it? Anyway, to explain these results, we need to know a little bit about electrostatic forces. Electrostatic attraction is where a positive charge and a negative charge attract. Electromagnetic repulsion is when two positive charges or two negative charges repel. As you can probably see, this is very similar to magnetism, which you've probably already done in physics, which is where two north poles repel, two south poles repel, and a north and a south pole attract. Knowing this, we can now explain the extreme angles of deflection that we saw earlier. Imagine a line of gold atoms. There are a few possible things that can happen. Firstly, the positively charged alpha particle can go directly between the gold nuclei. What this means is that the alpha particle isn't repelled by either and ends up directly behind the alpha source. Secondly, the alpha particle can move close by a gold nucleus. What this means is there's a little bit of repulsion and the alpha particle is deflected. Finally, if the alpha particle is going directly in line to hit a nucleus, it will repel by a very large amount, meaning that it's almost bounced back to where it's come from. And that's what we saw going on earlier. From this point on, the nuclear model was adopted. This is where we have a dense area of positive charge in the center, which we call the nucleus, and we have the electrons orbiting around the outside. Over the years, this has continued to develop, and we now have the idea of the nucleus not only containing an area of positive charge, but protons and neutrons. Thanks for watching this video. If you found it useful, please do leave a like, and also you can check out the link in the description, which has the relevant webpage. Thanks, and bye.